Everyone, welcome back. Today we are solving count the number of computer unlocking permutations. So this problem description is quite long, but I'll explain in very simple words. So basically we have a complexity array, and in this complexity array, each element is a computer, and only the first computer is decrypted so far. And if we want to decrypt another computer, we must find a computer with a lower value. And if we are not able to decrypt all the computers, then we return 0. And if we are able to decrypt all the computers, then we want to find the number of permutations that represent the order in which the computers can be unlocked. So if you look at this example, there are 2 ways, so return 2. We can first unlock this computer because this computer is decrypted, or we can start with this one since this one is decrypted, and then we unlock this one last because this value is still smaller. So as you can see, there are 2 ways to do it. If you look at this example, only this is unlocked, and since this is equal, you cannot unlock it. So now that we have seen some examples, let's get to how we can solve this problem. So for this problem, we should realize that after index 0, if any computer is less than or equal to the computer at index 0, then this computer can never be unlocked, or in other words, decrypted. So if this is the case, then we return 0. Otherwise, it's basically a permutation problem. So if we look at this, every value is larger than at index 0, so then we will take the factorial of the length of the array minus 1. So length of array is 4 minus 1 is 3, factorial of 3 is 6, and as you can see, there are 6 ways to unlock all computers. So basically what we will do is we will first check there are any values equal to or less than the original computer. If that is the case, then we return 0. Otherwise, we will take the factorial. So let's go with this example real quick. So first, we see all values are greater than index 0. So we calculate the factorial with this equation. Length of this is 5, minus 1 is 4, factorial of 4 is 24. So we return 24 as our result. So the time complexity will be O of n, where n is the number of elements in the complexity array, because it will take n time to check if all the values are less than the first computer. And the space complexity will be O of 1, because the space that we use will not depend on the inputs of the problem. So now let's get to the coding part. So first, we want to check if there's any values that's less than or equal to the one at 0. So we will look from 1 to length of complexity. If complexity of I is less than or equal to complexity of 0, we return 0. If not, then we will do the factorial, and we need to modulo by mod in case number is too big. So mod would be 10 to the 9th power plus 7, and we return factorial of the length of complexity minus 1, modulo by mod. Okay, let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave it in the comment section, and I hope to see you all again soon.